So what we are going to be doing is that GLM comes with some wonderful noise functions. It has classic Perlin and it has more modern simplex noise. And we are going to try and use simplex noise to create our world. At first we're going to use it just to create sort of a simple height map. And then we'll take it from there. So we're going to try and add a height map. So that means when we are a chunk here, we are going to, rather than do all of this for creating a sphere, which we're just going to disable like this. What we want to do is, as we're doing this sort of as a height map, we want the same sort of structure where we run through all the coordinates. But rather than doing x outer and then x, y, and z, we want to do x and z first. And then as we run through the y coordinates, we are going to be comparing them to whether they're above or below our height map. So what we want to do at this point is we want to calculate a height. So the wonderful thing here is that we can do height. And we're just going to do this really simple first. Height, GLM, simplex. We're going to do that for a GLM vec2. And this is going to be based on x and z coordinates. So simplex. And I also need to include GLM GTC simplex. No, noise. There we go. Then we are going to say if y is less than the height that we've got for this, we are going to set it solid. So far we can only do one thing, solid or air. So that's a little bit boring sort of, but we'll get to that another time. If it's above, we'll set it air. So we're quickly gonna try and compile that, see if that works. Yeah, it at least compiles. So we refresh and switch over. And we're getting something. Mainly a crash. So just a moment. I'll get Firefox back up. There we go. And OBS needs to know about the change. And that one. There we go. Switch you over. Gonna grab that one again. So, I mean, it's nice and blocky. So the problem right now is that simplex noise sort of generates between well, essentially 0 and 1. And so we're either getting one block or no blocks, and we'd like to sort of generate a little bit more than that. So what we are going to do is we're going to quickly switch back here. We are going to take our simplex noise and we are going to multiply it by 15 and add 1 here. So that means we're going to generate between 1 and 16. So either the max height or sort of having at least one block. And then we're going to try that again. So we link that together. We refresh. And now we're getting something that looks rather jaggy. This. So this is, I don't know what to compare this with. Apparently we're not generating between 0 and 1 because I can still see through the bottom. So we're probably generating between -1 and 1 or something like that. We can just try and look it up quickly. GLM simplex. See if they say anything about it. Nope, they don't say what the range is, but I'm guessing we're between -1 and 1. So given that, we're going to switch back. We are just going to say between multiply by 8 plus 8. Now, to sort of even it out, right now we're getting very sort of jaggedy, is because we kind of want to scale the simplex noise so that it is not just the raw x, y, or xz coordinates here that we sort of input to it, but we sort of want to multiply them down so that we get sort of a more smooth surface. So we're going to just start with some odd number that I've made up, in this case 100th. So trick here is I'm multiplying by 0.01 rather than dividing by 100 because old habits die hard, and in case the compiler is bad at optimizing, multiplication is faster than division. So right now, try and go out, view this from above. Now we're getting sort of more structure to it, but right now we're still repeating it. Every block is exactly identical, which is not really what we're looking for. So what we want to do is we want to, in addition to having sort of the local coordinates of the chunk we're in, we also need to add the chunk's actual coordinates to this. So in addition to having this, we also want to add, well, actually we can do that sort of inline. So we also want to do 16 times the x coordinate of the chunk, where 16 is actually size. And then we want to do the same with the z. So multiply that by size as well. We get to link that together. Oh, forgot to show you guys that. So in addition to just having x and z here, we are also putting the coordinates of the actual chunk multiplied by the size in, which will hopefully allow us to generate some more sort of consistent terrain. So if we move out again, we are actually getting something that looks decent. Now there's a discontinuity here and here as well. I am guessing that simplex noise does not like me inputting negative numbers, because this is probably sort of the positive quadrant. But I'd say that sort of the positive side here actually looks rather nice. I like it. So what we are going to have to do is we're going to have to sort of offset it somehow. So we're going to switch back here. We are going to define an offset. So we are going to have a constant expression, integer offset, and I think something along the lines of that 2 to the 30th again. So that's 1 shifted up 30. Wrong way. There we go. Should be nice. That should allow us sort of the maximum leeway in each direction. So we're going to add that in here, so that we add the offset as well. Link that again. Build it. So we are over here on the wonderful little display here. And let's peek up. Yeah, that was probably not the best choice. Guess is that due to this being floating point, we get weird stuff going on when numbers are that high. So we are gonna scale it down a little bit. I'm just gonna pick a sort of more sane number. So like 1024 should be good enough for us. We're doing 16 times 8, which is 128. So 1024 is bigger than that. However, this does sort of limit the size of our world. So we might want to look into seeing if we can use simplex on integers. The problem with that is that we have this wonderful little multiplication here at the end, which is unfortunate because that sort of divides everything down. But that's a problem for another day, I think. So let's just quickly jump over to our render again. See how that looks? And now we're actually getting nice, smooth-ish terrain in all directions. I think one thing I do want to do is I want to speed up the camera because it is really, really slow moving around. So we are just going to quickly look at the camera here. And right now we are doing motion speeds at like this rate. So I think multiplying by 5 is not too unrealistic. So we're just quickly going to try that. Linking together, and we've got it built. Switching over, reload. There we go. Now we can actually get some movement here. So this is sort of our first stab at terrain generation, and I'm pretty happy with that actually. So what we want to do, or what I would like to do, is sort of expand this and start generating both chunks above and below as well. You can see this wonderful thing inside here. So that we can sort of expand the scale a little bit. Because one of the sort of nice things about this kind of noise is adding multiple different scales of noise together. For example, this sort of works at a local scale. You've got sort of small valleys, small hills and stuff like that. But you'd also sort of like to have more bigger features so that you can get areas like oceans and stuff. Whether we're going to be doing that today or not is a little bit open. This has gone a lot faster than I expected it to. Of course, just calling simplex and then using that number makes life a little bit easier. But yeah. So we are going to try and add some chunks up and down as well. See how that goes. So rather than just having X and Z here, we are going to add in Y as well, so that we render up and down as well. And of course I need to change more than just the assignment. I need the comparisons. Otherwise I get a really, really crappy loop. There we go. Let's just start by seeing if this actually still works or if we run out of memory or something like that. You can tell it's taking a little bit longer to generate now. A lot longer to generate. I would like to wait in this case. There we go. We're not running out of memory. Frame rate is a little bit worse off. But right now we sort of get these layers because we're not taking the Y height of the chunk into consideration, which we of course also need to do. So when we are, sorry, throat's a little bit dry today apparently. So we have this height here. What we would like to do is we're going to sort of do an inverse thing here, is that we are going to subtract 16 times the size of this times, or the height of this chunk times size from it, so that we get not the duplicate declaration, of course, so that we don't get the height globally, but sort of locally in reference to this chunk instead, so that this logic down here still works. Allows us to do this multiplication outside of this final inner loop, so that this final inner loop is really, really simple, which is what we prefer. And I've already compiled, and I've forgotten to show you this. I'm out of practice, I'm forgetting a lot of stuff today. So what we did was from our height from before in the chunk here, we subtract the Y coordinate of this chunk times its size here, so that this is the height in this chunk. And then just like before, we're still comparing that to our local Y height here. And that compiles fine. So if we jump over to the browser and refresh, allow it to load. This takes a little while. And I want to wait for this script. There we go. So now we don't have sort of a height above us anymore. We're still, it's a little bit laggy because we're rendering a lot of chunks. Got a lot of these completely empty chunks down. Probably not the worst, but we also have a lot of empty chunks above us, which we could essentially say don't render to. So we're just quickly going to do one small performance optimization here. So in our chunk render, we are only ever going to do all of this. Only going to try and render anything if the size of our index buffer is greater than 0. So we've got all of this only if the size of our index buffer is greater than 0. So if there's nothing to render, don't even do anything. Of course, we're still going to take an eternity to prepare the data, because such is life apparently. Of course, this should become asynchronous with the rendering at some point. Also, it will be cached and not just be simplex calculation over and over again. But right now, we're just going to try and live with it being a little bit slow. There we go. So yeah, that feels like it helped a lot. I mean, we're still rendering a lot of underground that we don't need to, but so far so good. So let's try and see what happens if we change the scale of the landscape a little bit. So right now we're multiplying it by 8, so let's just say instead of multiplying by 8, we multiply it by something like 32. That should create a terrain that's 4 times as, what should you say, sort of 4 times as steep essentially. So let's give that a go. Now I forgot, did I just hit wait or did I just hit stop it? Oh, thank God I hit wait. So now it's sort of very hilly. I like this terrain. Simplex noise is fun. So the next thing that I would like to do here is I would like to sort of add what you might consider overhangs and stuff like that, because right now we've got this very, very smooth terrain with just a height map, but it's a little bit boring. Well, I like it, but it can be a little bit boring. So what would be interesting is sort of adding, a little bit more lumpiness and maybe some overhangs to it. So what we can do is we can use this sort of as a guide for the sort of height the terrain should have, and then add to that. So what we are going to do is that we calculate this height, and then rather than say yes or no to whether this should be set or not, what we're going to do is if we're below the height, we're always going to set it. But if we're above it, I want to calculate a sort of threshold. And then we're going to sample another simplex function, and we're going to use that to, well, essentially to determine whether this block, which would otherwise be air, is going to be set or not as well. So what we also want to do is we want to calculate, first of all, a cutoff. So what I'm thinking we do here is that at this point, when we're just above it, height, or then y is just greater than the height. So what I'd like to do is I would like to say that y minus height, and there we go. Sea lion apparently isn't my band today. My machine a little bit right now. Yeah, lost the WebGL context, so a little bit of a driver crash, I think, there. So hopefully I can see that I've managed to forget to switch over again. So when our height is close to the y, what we want to do is we want to calculate a cutoff point here. Basically going to base it on y minus height, but we're going to smooth it out a little bit by saying times maybe 1.1. And then we are going to take a look at sampling a simplex function. This time it's going to be a 3D simplex function, which I don't know what we're going to call it. We're going to call it noise, because it's a sampling of the noise function. So this time we're going to go in 3 dimensions, which means we're going to sample y plus this y times size plus the offset. And we want smaller scale structures for this one. So we're going to multiply this by 1.0, and we're going to not offset the noise. And then we're going to go for sort of the same idea here. So question is, which direction does, so as y grows bigger, this cutoff is going to grow more positive. So as long as noise is below the cutoff, then we are going to have this block be set. Otherwise, we are going to leave it as air. I'm really curious to see how this looks. I need a semicolon there. Link everything together. Try and reload. Now this will only have gotten more expensive now. Just wait for that again. Still gonna wait. There we go. Okay, this seems very wrong. Also because it looks sort of like this is the opposite way of what I wanted to do. Sort of creating holes the other way around. So I might have gotten the cutoff wrong. Let's just quickly switch back to chunk code here, and if noise is greater than cutoff, oh yeah, of course, as cutoff grows, this will happen less and less often, and we'll get error at the end. So that makes perfect sense. We'll try that one more time. I'm still gonna wait. think what we're going to do after this is that we are going to try and separate this out so that we generate the chunks asynchronously, which does mean that the chunk renderer needs to be able to detect that a chunk updates. Wow, that changed it. So we've still sort of got the same basic landscape, but we're now also sort of trying to add outcrops to it. And it, again, Firefox does not seem to like me today. Probably a matter of using a lot of memory and my graphics card apparently not liking me that much. So we're gonna go back here and pull that up. Transition back. But anyways, we were also getting a lot of sort of loading blocks. I'm assuming that we're loading something right now. Yeah, we're loading. Great. And apparently I got it to reload a second time, because anything else would have been too easy. We're still gonna wait. I have plenty of patience, or something like that. There we go. So we're both getting sort of overhangs and other weird formations. It's looking a lot more interesting. But we're also getting lots and lots of floating blocks. Whether or not that's a good thing or not, I can't really decide. I mean, it makes it interesting. But you see, we get these sort of kind of cave formations. I kind of lost it there. Here we go. Where we're actually able to pass through a hole. So that's nice. It's definitely a lot more interesting to look at. There's a lot going on here. So yeah.